Okay, so I'm looking at number one. Um, maybe we call maybe we call this x to the fifth. We'll call it the length, and this x squared. We'll call that part the width. Okay. So when we do area equals length times width, that would be that the area is x to the fifth times x squared. Actually, that one gets added. Remember when the base is repeated, and this is the one that is most often confused, is when do I multiply, when do I add? In this one, we're going to do 5 plus 2, and that's going to give us an area of x to the 7th. So it says express the area as a monomial. This is called a monomial. This is a degree. It's the 7th degree monomial. So we're just using the properties that we've been practicing the last 2 days. Okay. Let's do number 2. We'll do area is CD times CD. This length, this width are, because they're the exact same thing, that means it's a square. So we multiply both of those. Well, they have these invisible exponents of 1, right? If there's no exponent, the invisible 1. So this would be C 1 plus 1, D 1 plus 1. So that area is C squared D squared. Funny that it's the side length squared and we call it a square. These things are related on purpose. Yeah?
So in number 3, when I divide like the answer, do I divide also the exponent?
Let's take a look. I think I've run out of room, so I'm gonna do mine on the board. So for our triangle, we'll use this formula. We'll call not, oh yeah, I already labeled B and H up there on the screen. So B is 9p to the third. H is 4p. And we're dividing it by 2. So, great. We'll multiply the coefficients, the 9 and the 4. 36. And then we add p3. And this has an invisible 1. So that's going to give us p to the 4th all over 2. So no, in this case, you don't mess with that. You're just dividing 36 in 2. Good question. So now, when we simplify this, it's just reducing the 36 over the 2. And that answer will be 18p to the 4. Any questions on Boer? All right, we're going to go ahead and move on to taking some notes on our new section, chapter 6-2. There you go. You know, higher roots you may not be as familiar with. Oh wait, God. I'm gonna make you write down a whole bunch of stuff first. First, this is what I knew I wanted you to have a calculator. First, I want you to make a whole list in your notebook. This is gonna make your life easier. I wouldn't make you do this unless I thought it would make your life easier. To have a list of these numbers raised to different powers. Now, you probably know these ones by heart. These ones you're less familiar with, and these ones will sure be a lot easier if you have your calculator. Okay? If you're not sure how to do an exponent in your calculator, ask somebody around you. The button looks like YX. This is your exponent button. So try it with one you know. 3 squared equals 9. So try to use, it goes 3, and then YX, and then 2. See if that gives you a 9 out. Try it. This little dinky calculator. Yeah, 3, YX, 2, and then 9. That's how you do an exponent in your calculator. A lot button there.
You're just as bad as Atlas. You're so slow. Oh my god. Oh, sheer brain cells.
I used to hand out calculators, and people walked away with them. So I just have to stop. I can't keep track of it too much. So I'm making right now for the calculator today.
Oh my god, dude. I did always the same thing.
Okay, thank you for telling me.
Okay.
Jay. Jigger. You want to do some damn work?
I just got you.
Really got to do that.
You're the only person that made it. I was done with it.
That's why I told you you only need to do drink.
Okay, here we go. Three times 3 is 9. If you didn't write it, it's okay. Just write 4, 9, 16. 5 times 5 is 25, right? Gosh, should I keep going? I'm just gonna put the other ones here. You don't have to. Oh my gosh. Alright, 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. Okay. These numbers that we're quite familiar with, 36, 49, 64, 81, 100, those are all called perfect squares. That's what mathematicians decided they should. Well, I'm going to say it a lot. Perfect squares, they're like celebrities in the math world. We use them a lot in both, well, in all the maths, really. Okay, so let's go to those third degree ones. Okay, I said these are third degrees. They're numbered to the third power. So for this one, it would be 2 times 2 times 2, and that's 8. 3 times 3 is 9. Times 3 again is 27. 4 times 4 times 4 is 64. It's an interesting one. 5 times 5 times 5, 125. And that's all you had to write down. I'm going to do a couple more. 6 to the third power is 216. 7 is 343. There's another one that's 243. I think 3 to the fourth is 243. 7 to the third. Yeah, 343. 8 to the third, 512. 9 to the third, 729. 10 to the third, 1000. If you just wrote down the first few, that's okay. Now, these numbers, they're not called perfect squares. These numbers are called perfect. Triangles is a great guess, but they went with cubes. A cube is a third degree. They went with cube because when you find the volume of a cube, you do length times width times height. It's three-dimensional. So a third degree is like a three-dimensional volume, cube. All right, perfect cubes. And now we'll do numbers raised to the fourth power. Okay, so we got 2 times 2 is 4 times 2 is 8 times 2 again is 16. 3 times 3 times 3 times 3, 81. 4 times 4 times 4, 256. 5 times 5 times 5 times 5, 625. 625. All right, so there they are. There's your numbers. Don't do that. All right, so the opposite of raising a number to an exponent, like we do 5 to the 4th, you've done that quite a bit. The opposite of doing that is to take a root and to use a radical. Now, you've done square rooting before, but the truth is you can do the opposite of any exponent, not just a square. You can do a fourth root. So because 2 to the 4th is 16, if I use a square root bar, but I put a little baby 4 inside of it, that means I want to do the opposite of a power of 4. It's called a fourth root. Notice this is a square root bar. It's really called a radical bar. If you put a little baby 4 in it, you're taking a fourth root, not a square root. So the fourth root of 81 is 3, because 3 times 3 times 3 is 81. The fourth root of 256 is 4, and the fourth root of 625 is 5. Yeah, it's not really division, it's undoing an exponent. It's like dividing by itself that many times. Let's find the button on your calculator.
No, it's
Dividing by itself the number of times of the exponent. The right side, JC's right. There is a button on your calculator that will do it. So let's try it right now. Let's do the fourth root of 256 on this calculator here. We're gonna go 4 root 256. No. 256. 256. 4. Good. All right, so in your calculator, you're going to do 625 first. And then you do the bright green second button. And then you do this button. And then you hit the 4. And then the equal. So it's the 625, or the, 256. I dropped it. Yeah. Yeah. So 256 second, this one 4, and then we'll do it. Try it, Ron. You know how to do it, Ron? So as you're doing the 4 through 256, you put the 256 in first. Second, y to the x and the 4. Every calculator you use after your EOCs does it more clearly than this one. Do you want to learn it? It's too much to learn? It's worth it. Just try it. You got your calculator. You might as well try it. You just this green button. And then this one. Okay. All right, let's get back at it. Here we go. So here's your actual we're going to practice different roots, starting with square roots, which you've done before, right? So number 1, go ahead and write down what is the square root of 49. You can use a calculator, you can do it by memory, or you can find it in your list. Okay? Are you guys all ready? I'm telling you ahead of you. Alright, I know that the square root of 49 is 7, and that is because 7 squared is 49. One thing you probably have never been told before is that all along there has been an invisible 2 right here. When you square root, the little 2 is invisible. We can put other numbers there. They started centuries ago when they did the opposite of exponents. They only thought they were ever going to square root. They didn't think they were going to fourth root or cube root. So they just put a little number in there. And then someone was like, well, hey, let's do the opposite of other powers. And that's when they started writing numbers in there. So the 2 is invisible. But it's there. And what's the square root of 64, guys? That's 8. And that is because 8 squared is 64. Opposite of squaring. So, like, talking about dimensions, like we just did the area of a square, but when they started calculating, so this is length and width, right? When they started thinking about volumes and 3-dimensional figures, that's length, width, and height. That's something with a third power. Our third dimension needs to be cube rooted. Instead of squared, it's cubed. So now we have to do cube roots. And then if there was a fourth variable such as time, temperature, maybe a movement, and then we would do a fourth root to write that value down.
So they did all of that to cover all the variables.
Yes, exactly.
Okay.
Bringing in more things than just 2 means we need that higher operation. Exactly. Yeah. She gets it. That's good. Alright, let's do cube roots. Practice cube root. Just finish it when you start it. See if you can say. Okay. So, to do the cube root of 8, I'm going to think to myself, what to the third power is 8? So go back to the list. You guys have a list on your power. Is anything raised to the third power equal to 8? It's 2. So the cube root of 8 is 2. You guys are just getting this right away. That's awesome. Now, 64 is a trick. Because 64 you can square root and you can cube root. 64 shows up in the perfect square list and the perfect cube list. So the square root of 64 is 8. So if there wasn't a number here, I'd be writing 8. But this time, the little 3 means I'm looking at the list of 3's. Where does 64 show up in the list of 3's? 4. You see it, Ramsey? See the 4 there? Yep. Use your list. The list is helpful. Alright, let's do some fourth roots. Am I going again? We're going to 5 and 6 when you're ready and try a fourth root.
What's 9?
Oh.
It's actually more of a rose.
Alright, does 16 show up in your list of things to the fourth power? I know 16 squared is 2 before, but does it fourth root? It's 2? Another 2. And does 81 show up in our powers of 4 list? Did you write 81 down? Yeah. There it is. I think you're getting it. Hey, here we go. Oh no, I have a note. This one's gonna be really confusing, but let's do it. Okay. Are we ready? Are you guys done with 5 and 6? Are you ready? Ashlyn, are you done with 5 and 6? Yeah. Megan, are you done with 5 and 6? Wait. All right, here we go. Big time note. Good. That's a good start. Okay, I can't make start. Next start. That is so nice. Way to really dress it up. All right. Well, here's a new moment. Roots can be also written as fraction exponents. Okay, so this is kind of a big topic right now in Algebra 2 as well. So a cube root, and you can do this in your calculator if you're good with parentheses. It's the exact same thing as 8 to the 1/3. So not only are there other types of roots, exponents can be fractions. Has anybody seen an exponent that's a fraction? No, it's your first day. Okay? Exponents can be fractions. That crazy? Why didn't he tell you this long ago? I don't know.
But there was a person who asked the question if exponents could be fractions, and you said no.
Oh, really?
Yeah.
When was that?
That was like a day, like 2 days ago, I think. We had started this, and someone asked you if exponents could be fractions, and you said no.
Was it it's probably your case asked a particular problem.
No, that's not me. She asked.
But if you can remember it, I'd like to revisit it. But when exponents are fractions, 32 to the 1/5. Okay. The third root of 27 is also written as 27 to the 1/3. Are you guys okay with that? Let's try 1,000. The third root of 1,000 is also written as 1,000 to the 1/3. It's equivalent.
That's crazy.
That is crazy. Okay, guys, so I want to show you this in your book. Well, I don't want to show you that at all, actually. Okay, so here's your first 4 problems today. I'll write the assignment here. You actually don't have these book pages yet, so we're gonna pause. I'm hoping you guys can get